Hi, I'm Sanjay Nagchaudhary, Development Lead for the IBM App Connect Enterprise product. In this video, I will be following on from the previous video where I introduced how to access the context tree using the Java Compute node. I will use a Java Compute node in the subflow and show how to access the input node which was used to invoke the parent message flow using the built-in Java plugin API. So in the previous video, I introduced the context tree and gave an example of how to access payload data from earlier nodes in the message flow using the Java Compute node. The context tree is a new tree in the message assembly which is not captured by default. It is only made available in the message assembly when it is referenced. The context tree has information about how the message flow was invoked and context information from every message flow node, including payload details. In ACE 13.0.5.0, the Java plugin API has been updated to allow access to the context tree. This allows the Java Compute node and Java plugin nodes to access the context tree. In order to use the context trees in Java, the enable context tree usage method must be used in the onSetup method. When enable context tree usage is called, it will switch on context trees for the message flow before any flow threads are started. New classes have been provided to access different parts of the context tree. So in the demo, I will continue with the message flow from the previous video, which was using a single message flow. I will move the Java Compute node and trace nodes from the main message flow into a subflow. And in the main message flow, I'll add an extra HTTP input node. So there will be two input nodes. I'll then show a simple code change, which allows you to access the input node without explicitly stating the name of the input node that is used. This is done by using the getInvocationNode method on the MB context tree object. Okay, so this is the message flow that I was using in the previous video. I have a HTTP input node, which takes a JSON message. I have two REST request nodes. Each is calling an operation to a REST API. There are two separate REST APIs deployed to my integration server. And the Java Compute node has Java code, which is taking the output from the previous nodes. So it's taking output from the input node, from the first REST request node, and from the second REST request node, and forming a response and sending it back. It is doing this by accessing the context tree. The two REST APIs have been imported from a tutorial called Aggregation Nodes using REST Async Request Nodes with Backend Services. You can import that tutorial by opening the tutorials gallery, and if you search for REST, you can see the tutorial and you can then import the projects from that tutorial. After importing the projects, you can deploy the two REST APIs to an integration server, and then you can follow along this example. Okay, so the Java code was done in the previous video. I showed by step how to create the Java code, and I am going to make some changes in this video to use a subflow. Let's start by deleting those two wires. Let's create a new subflow. Let's call it use context. And I'm simply going to copy that Java Compute node into here. And I'll copy the trace node into the subflow as well. Wire it up. And let's delete these two nodes from the main message flow. And let's use a subflow node to call the subflow. And I am also going to add an extra HTTP input node. So if it's currently called HTTP input, I'm going to change that to HTTP input Sanjay, and I will add an extra HTTP input node, and I'll call it HTTP input Ben, and let's add the suffix, path suffix, context demo dash Ben. The other input node has context demo dash Sanjay as the path suffix. Let's make sure that the input message domain is JSON, as a JSON message will be used. And let's change the client wait time to 600 because I'll go through the debugger as well. So let's save that. So we have two input nodes. Let's go to the subflow and open up the Java Compute node. Now in this Java Compute node, I am explicitly stating that I want to get the node HTTP input. Well, there is no HTTP input node now because I changed it to HTTP input Sanjay and then HTTP input Ben. But what we can do anyway is, rather than explicitly stating the name, we can use the method get invocation node. This will return the input node that was used to invoke the message flow. So that will then be assigned to this MP context tree node variable called input node. Note that even though we're in a subflow, we are using get node for get backend 1 and get backend 2. The get node method will search all context tree levels for the node name that's provided, and it will return the MB context tree node object that represents the node. If the node name can't be found in the hierarchy, then null is returned. This will work even though it's not in the subflow, it will find it in the parent message flow. So that's all the code changes I needed to do. Everything else stays the same. So the only code change I've made from the previous video was to change the method from getNode to getInvocationNode. That's all I've had to do, and it's now being used inside the subflow. So let's try it out. So I'm using the flow exerciser, and I'll send a message to HTTP input Sanjay. And when I send the message, I send the input message and I get a response. And that's the response that I'm expecting. And if I look at the message assembly before I call the subflow node, if I look at the context tree, we can see in invocation details it has the node name here. So this allows the code in the Java compute node to get the input node by using the name through the invocation details. Note that in the subflow, it will only have visibility of the input that came in. So the input that came in was from the output of the previous node, and that was from the last REST request node. So the output from the last REST request node was literally this payload data here, this data from second REST API. That's what comes into this subflow. But the Java compute node can still access the nodes from the different context tree levels. So let's try sending another message. Let's try sending name Ben to the other input node, HTTP input Ben, and send that. That's the input message, and in response I get name Ben. And if I look at the message assembly, the context tree shows the HTTP input Ben was used as the input node, and I can access the payload from there. Let's try putting a breakpoint after this method here. So it's getting the input node. Let's launch the debugger. So let's send a message to the flow. And the debugger stopped at the breakpoint. And we can see that the input node has been passed. So this allows the code to access the input node. If I put a breakpoint later on in the code and carry on to the next breakpoint, this shows that get backend 1 node was found, and as I said before, it searches all context tree levels to get the node. So even though it's not in the subflow, it finds it from the parent flow. And the response message is returned. So in this video, I have shown how to use a Java compute node in a subflow, and I've shown how to access the input node when there are multiple input nodes in the main message flow, and it accesses the input node using the getInvocationNode method. And I've explained that the nodes can be retrieved from all previous context tree levels.